Hi, I'm Paul Dansbach, and welcome to Fire Engineering's Training Minutes. In this session of Training Minutes, we're going to take a look at an ordinary constructed building that has a heavy timber wood truss roof. We're going to talk about some of the fire problems of trusses. One of the biggest fire problems of trusses is that there is poor surface to mass ratio. Another fire problem, particular to this building and many other buildings that are out there, is the fact that the truss loft has been converted to a storage space. As we look at these trusses, we're going to see what was at one point a wide open space has been converted to a storage area. A stairway has been installed, a floor system has been installed. That floor system is supported by the bottom cord of the heavy timber wood trusses. The heavy timber wood trusses were never designed to support the load of that floor and the materials that are stored up in that storage space within the truss loft. Let's review some of the fire problems created by a truss of this nature. First of all, access to the storage space. Access to the storage space in this building is via this stairway. The stairway is very limited in size and very steep. Advancing a hose line up that stairway will be challenging. Another fire problem created by the truss construction is the large volume of space up to the ceiling or the underside of the roof deck. If there's a fire in this building, that space is going to allow the heat to accumulate before the true condition is felt at floor level, often disguising the true fire conditions to firefighters operating at floor level. They may not understand the volume of fire that exists above their head. When this building was originally constructed, there were no obstructions to the underside of the roof deck. Firefighters could easily apply a hose stream from the floor up into the truss space and extinguish any fire that was up in the truss space or burning on the underside of the roof deck. As a result of the alteration and the addition of the storage loft to the trusses, firefighters no longer have the ability to apply a hose stream to the burning material or the burning structure located above this floor decking. That's another limitation and another hazard that this alteration has presented to the firefighters. This is a hazard that's very common in buildings of bowstring truss roof construction. We're looking at the exterior wall of the building. We're going to look at the point where the roof slopes down to the exterior wall. What we're looking at is rot and deterioration of the roof decking. That rot and deterioration are the result of years of water leaking through the roof and deteriorating the wood roof structure. This is an area where if firefighters are walking across the roof, they are likely to fall through the deteriorated roof decking and into the building. As the result of the additional weight imposed on the bottom cord of the trusses, the owners of the building have attempted to support the trusses in another manner. Here we see a steel column has been installed along to support the bottom cord of the truss. Additionally, steel U-channel has been bolted to the bottom cord of the wood truss in an attempt to make the truss more stable and able to support the additional load imposed on the bottom cord by the floor decking and truss loft. Okay, we're up in the truss loft area, again, up in the space that has been created by the installation of the floor on the bottom cord of the trusses. Let's take a look. Here we see the top cord of the truss, we see the web members of the trusses, and we see how the web members are attached to the bottom cord through the use of threaded rod. As we look through this truss loft space, we're going to notice that the building has been deteriorated as a result of the age of the structure and the loading of the truss loft. As we look around, we see a rafter. This rafter has split as a result of movement of the structure, loading of the structure, deterioration of the structure. We continue to move around, and we're going to look at the next truss over. At the top cord of one of the trusses, we can see that there are 3 web members that are damaged where they attach to the top cord of the truss. All 3 of the web members are split and pulled from the top cord as a result of the load imposed upon the bottom cord of the truss. The weight imposed on the bottom cord of the truss is attempting to pull the two cords, the top and bottom cord, apart from each other. Notice the cracking and splitting of the lumber as we look at these web members. Another indication of the amount of damage is how far the web members have been pulled from the top cord, and this is indicated by the paint line on the web member that you're currently viewing. Understanding truss construction is of paramount importance to all firefighters. Firefighters should identify all the buildings in their jurisdiction that have some form of truss construction. Additionally, visits to these structures will help firefighters understand the firefighting challenges and problems posed by these buildings. Thanks for watching this session of Fire Engineering's Training Minutes.